Hello friends, welcome to lecture 4 of games theory. So in this lecture we'll be discussing about subgame. Now in the first 3 lectures we have discussed about pure strategy, saddle point, we have discussed about mixed strategy, and we have discussed about algebraic method, shortcut method and rule of dominance. Now in certain cases, when the matrix is greater than 2 by 2 matrix, for example in this case it is a 2 by 3 matrix. Now for this matrix, payoff matrix, there is no saddle point, and you cannot apply the rule of dominance to reduce further this payoff matrix. And if the matrix is 2 by 3 or 3 by 2, then we can apply the rule of subgames. This subgame method can be applied. Of course, this can also be solved by graphical method, which we'll be discussing later on. But this can be this type of problem. Typically 2 by 3 and 3 by 2 problems can be solved by subgame methods. So let us start discussing how to solve such type of problems. This is a matrix, payoff matrix, where A has 2 strategy and B has 3 strategy. Remember the number of strategy of B is more than 2, that is 3. Okay. Now what we'll do is that we'll divide this payoff matrix into 3 subgames, where A has 2 strategy and B has 2 strategies. So these subgames may be A12, B12, A12, B13, A12, B23, like that. So you can divide this into 3 subgames, and for all these 3 subgames we'll find out the value of the game, and we'll find out the value of the game for which the value of the game is minimum will be the solution of the game, because B is trying to minimize his maximum loss. So for the game in which the B is the value of the game is minimum will be the solution of the game. That means that strategy, suppose if it is the strategy 2-3, then A can choose either 1 or 2, and B can choose either 2 and 3. If this is the value of the game, which is the smallest among the 3, then the strategy that B will follow is 2 and 3, and B will never follow the strategy 1. So the probability of B following strategy 1 will be 0, and the value of the game will be this game will be the value of the larger game. So we'll start solving the subgame 1-2. So subgame 1-2 is there. Again, for each of the remember very carefully, for each of the subgame you will try to find out the saddle point. That is very important. Do not proceed, I repeat, do not proceed without finding out the saddle point. If only there is no saddle point, that means that is a mixed strategy game, and then you will solve it by other methods. So do not proceed without finding out the saddle point of the game. So if in this particular game there is no saddle point, so we'll solve it by the shortcut method, and the value of the game is there exists a saddle point, and the saddle point is the cell 2, and the value of the game is 1. So similarly here we'll try to find out the saddle point of game 1-3. There is no saddle point, so the value of the game, this is a formula method, you can find out, or you can find out by the algebraic method. The value of the game, it comes out to be 11 by 8. Similarly for game 2-3, there is no saddle point, and the value of the game comes out to be 5 by 3. So all 3 games says this value is the minimum, so this will be the solution of the larger game, and B will never choose strategy 1, rather B will choose strategy 3 and 2. So this is the solution of the subgame. So this is how we solve subgame problem. So here remember it is 2 by 3. So let us solve another problem which is 3 by 2. Since player B has n more than 2 strategies, the subgame minimizes the profit of B and need to be selected to optimize the solution of the larger game. So subgame 2-3 will give the solution of the larger game. So here it is a 3 by 2 matrix. So here A has more than 2 options or 2 strategies. So here we divide it into 3 games again, and the value of that game which is the largest will give you the value of this particular larger game. So we'll divide it into sub games. So these are the various sub games and we'll solve it. So in solving this, again we'll check each before we start the saddle point, and if there is no saddle point, then we'll solve it by the algebraic method or by the shortcut method. So here it is coming out to be 3.71. Game 1-3, there exists a saddle point. So please be very carefully check for saddle point. If you don't check and if you go on solving it by algebraic method, then you will get it wrong. So if there exists a saddle point, so you have to find out the saddle point. So value of the game is 3 here. So it is 3.71. This is 3. So obviously this is greater, and 2.3 it's coming out 3.67. So this game 1-2 will be the solution of the larger game. So similarly you can solve other problems. Try to solve this one yourself. Pause the video here and I'll show you in a few seconds the value of the game, which game, and the sub games and the larger games. Try to solve this yourself. Pause at this point of time the video and try to solve it yourself. So if you have learned it correctly, you should hear it patiently and carefully. You should be able to solve this problem. So we have divided into 3 games. So there exists a saddle point 5. This is 5.375 and this is 4.66. So it is the smallest one. So this will be the value of the larger game. So this is how you solve the payoff matrix, particularly 2x3 and 3x2 payoff matrix, which cannot be solved by the saddle point method and cannot be solved by the rule of dominance. So I hope you have understood this method, and we have came to the end of this lecture. Thank you for watching this video.